welcome back to my YouTube channel. Today I want to talk about the half angles. So we are basically going to verify or prove the half angles. There's going to be three of them: the sine theta over 2, the cosine half angle, and the tangent half angle. So let's see in this video if I can do probably two of them, and then I will do the tangent in the next video. Once we do all the three, then we are going to actually do some examples on the half angles. Guys, we have already covered the basic Pythagorean identities. We have covered the sum and the difference identities. Then we also covered the double angles, and now this is the half angles. Okay, so the half angle, this is the half angles. The first one that I'm going to write here is the sine of an half angle. So half angle, that's why we have a theta over 2, and that identity for the sine of theta over 2 is equal to plus minus radical of 1 minus cosine theta divided by 2. Okay, so guys, there are a few different ways to actually verify this, but let us start with something that we learned in the previous videos where we talked about the double angles. Okay, so guys, in the double angles, remember we talked about the fact that the cosine of 2 theta equals to 1 minus 2 sine square theta. Guys, this is from the double angles. Okay, we already know this from the previous videos on double angles. Fine. Now here's the thing, what we can do here is I'm going to, instead of using 2 theta, I'm going to divide this by 2, and we're allowed to do that. Like, instead of working with 2 theta, we're basically going to work with theta. So guys, look here carefully. So I'm not really actually going to divide this here, but internally I'm kind of, instead of using the 2 theta, I'm going to change it to theta. So which means I'm basically dividing that angle by 2. So I'm dividing this angle by 2 means it's going to be half of what it is, right? So if I have to write the formula for the cosine theta, so I'm just rewriting this formula, but instead of using 2 theta, I'm using just the theta. Okay, so we reduce this to half, this 1 stays. Then what happens here, instead of theta now, since we reduce this theta to half, we are also going to reduce this to half as well. So guys, let us go back. This is something that we already know from the double angle identities. From this we can write this as well, because here it is basically the same thing. The only difference is that, well, for us to be able to like understand this one has to understand this one carefully. Like, what does this actually mean? It means when this angle is 2 theta, here the angle reduces by half, it becomes theta. Similarly, when the angle is theta, this angle on the right hand side is going to be reduced by half as well. It's going to be theta over 2. Okay, so that is the most important thing that one has to observe in this original double angle, cosine double angle formula, to be able to get this. Okay, so from here, this is something which is already on your formula sheet. This is something that we already know from the prior videos. From this we can deduce this one. Okay, now from here, see what we are going to do is, since we want the sine theta, so we want to isolate this piece. To isolate this piece, first I'm going to subtract 1 from both sides, and then we're going to divide both sides by negative 2. So this is how it's going to look like. So it's going to look like cosine theta minus 1. This one crosses out, and here I'm left with negative 2 sine square theta over 2. Since we are trying to solve for sine theta, the first thing we want to do is we want to divide both sides by negative 2. When I divide both sides by negative 2, well, these negative 2's cross out. Guys, I'm going to write this sine square theta on the left hand side, because that's what we are trying to solve for, and whatever we are trying to solve for, we want to keep it in the left side. And guys, when we divide this whole thing by negative 2, well, we cannot really divide it, and we should not even try to really divide it, because we see the right hand side looks something similar to that. So we already know that we only have to get rid of this negative, right? So if I distribute this negative upstairs here and here, I'm finally going to end up with 1 minus cosine theta divided by 2. Because this negative, when I take it upstairs, this becomes negative cosine theta, that's right here. And this negative, when I take it upstairs and distribute it with this negative, it becomes a positive. So that's why I have a positive 1. So it is 1 minus cosine theta divided by 2. Okay. Keep in mind, this is theta over 2 in parentheses. Now we want to get the sine theta by itself. So from here, guys, from here to get sine theta by itself, all we need to do is we need to take the square root on both sides. That's how we get rid of the squares. So if we take the square root on both sides, this is what we get. We get sine theta over 2 equals to, but since we are taking the square root, we know we got to put both the plus and minus signs, and inside the radical I have 1 minus cosine theta over 2. And guys, this is exactly what the half angle identity for sine theta over 2 is. So we were able to verify that the sine theta over 2 is equal to this expression on the right hand side just by using the cosine of a double angle identity. So basically we are verifying something from some things that we have already learned prior to this. Okay, so that's the whole thing, idea of like verifying or proving things in mathematics. You already learned something and then the other thing builds upon that. So you can use the previous learned things, formulas, identities, rules, in order to simplify or solve or verify new things. Okay, that's exactly what we did here. Yes, the key thing was to realize that this formula means that when there's a 2 theta here, this reduces by half. Similarly, if I start with theta, then it is going to be theta over 2. And here we want theta over 2. That's why we simplified it like this. Okay. Now there's another way of actually doing it. I'm not going to show you that, but I mean, I can give you a hint if you like to do it on your own. You can also work with this cosine theta on the right hand side, and from there you could get the left hand side. But guys, it is up to you which side you want to choose to actually do something like to verify things. Okay, sometimes we want to choose the left hand side, sometimes right hand side, but it's totally up to you guys. The last thing I want to say about this before we move on to verifying or proving the cosine or writing the cosine of the half angle, guys, the plus and minus here, so whether we can have a plus value for the sine theta over 2 or a minus, it depends on which quadrant where the theta over 2 angle is. So here we're not only thinking about theta, we're thinking about theta over 2. So if theta over 2 is between 0 and 90, then we know it's the first quadrant, right? If theta over 2 is between 0 and 90, then it's going to be positive. We know sine is positive in the first quadrant. Guys, if it is in the second quadrant, which is 90 to 180, then sine is still positive. It will still be positive. And in the other two quadrants, which is the third, I'm not going to write the whole thing, and fourth quadrant, we know the sine of an angle is negative in both the third and the fourth quadrant, so it will be negative in those quadrants. And I mean, you will see it when I show you an example, but this is like a formal definition, and that is why we have plus and minus values here as well. Okay, and same thing will apply for the cosine and tangent as well, because sine, cosine, tangent, they are not positive everywhere in the fourth quadrants. They are positive probably in two quadrants and negative in the other two. Okay, so guys, this is sine theta over 2. In the next video I'm going to talk about the cosine theta over 2.